Hello, class. Hello, class.
Professor Smith here. Let's take a look at parabolic motion in a little more detail. What we said last week was that let's take an object and let's throw it off the top of a building. And if we throw it horizontally off the top of the building, then it follows this parabola, and it eventually hits the ground. Okay, so this is X, and this is Y. Now let's think about our motion diagrams for a second. When we talked about motion diagrams, we always drew things like this. We always drew things like X and Y as a function of time. So if this is Y, I'm going to draw this up a little higher, Y, as a function of time, right? And, whoops. So, same difference. If I started up here at H, then it would go just like this. But we just said that this thing was a parabola. And yet this was Y as a function of X. Y on the vertical, X on the horizontal. We said that Y versus X gave us a parabola. But now we're mapping something totally different. Now we're mapping Y as a function of time. Is this a parabola? Or is this not a parabola? What do you think? It is a parabola. They said that it was a parabola. Why is this also a parabola? Because the kinematic equation has t squared in it. Let's solve that kinematic equation. So here we go. So we're going to write it out. Y sub f equals y sub I plus v t plus 1/2 a t squared. And we said let's let h be the height that it starts at. So we have this is just going to be the same thing. And then h is going to be the height that it started at, y initial. So if we just said that, how does that function y changes the position of time? Now y initial is h, vy initial is 0. So we can just rewrite vy initial as 0, the velocity before you threw it. And so now we can just rewrite this as the same as it is up there. So we can just rewrite this equation as this. Okay? So is this the equation of a parabola? Yes, because it has a t squared in it. It's quadratic, right? It's going to be inverted, of course, because it's going to have a negative sign, because we started up here at h, so it would be h minus, because gravity is negative here. Oh, wait a minute, though. Hold on. Now, we said that this was a parabola. But maybe it's not. Is this guy a parabola, then? What do you think? Maybe it's not. Huh? You think both are parabolas? Because I drew them so carefully? They're both the perfect curve? I think you're right. I think they are both parabolas. But why are they both parabolas? Well, to understand this, let's map out x as a function of time. What we just mapped out was y as a function of time, but if we map x as a function of time, what do we get? I actually don't know, so we have to go back to the kinematic equation. So here, x final equals x initial plus v initial times t plus 1/2 a sub x t squared. All right, now we're going to give the initial to you. And we can also say that xi equals 0. So x as a function of time now, so we know that, so v xi times t plus, what is a sub x for projectile motion? There's no acceleration, so it's 0. So now we get an equation x equals vxi times t. I have my y here, I have my x here, and if I map x as a function of time, what does it look like? What would this function be? A line. It would just be a line. And in fact, the intercept is 0, and it's a line. It would just look like this. This is x as a function of time. All right? And that is parabolic motion.